Hello everyone, can you hear me? Let me... Hi, please confirm if you can hear me right now so that we can start the stream. How was the contest today? Okay, awesome. Did you have a good contest? Did you enjoy it? Worst? Why? Well, that's bad. Oh, this was your first contest. That's awesome. That's awesome. How was your first contest? Did you enjoy participating in CF contests? Let me make my picture smaller as well so that we can start. Okay. Oh, I see. Yeah, that happens sometimes that your code works well on your own system, but when you submit it, you don't get to accept. That sometimes happen. It might have many reasons. For example, the main reason can be because you have some variables that you have not set them, and that makes your answer, by random work on your own system, but it doesn't work on Codeforces. Okay. 7 problems also. Voice is low. I'm not sure that's what is the issue that voice is low. Everything is maximum. That's me. Is it better now when I'm closer to the microphone? Can you hear me better now? Okay. Okay. Okay, awesome. Awesome. So, shall we start discussing the problems? And finally, Codeforces run a contest. It was a long time that there was no contest in Codeforces, and it was so bad. Finally, after a while, we have a contest. That is very good. Okay, let's start talking about the problems. The first problem that I want to discuss is problem A. It is an easy problem. It just says that you're given two integers x and y, and you have to output two integers, the minimum of x and y followed by the maximum of x and y. Well, this is very easy. You take x and y and you just write a if. If x was if x was greater than 1, you just swap x and y. You just change them, change their values. So you say that if x was greater than y, you just swap them. Then you are sure that after doing this, x is your minimum and y is your maximum. And you can write x and y. There was also another way. You see in x and y, and you see out minimum of x and y and maximum of x and y. Both works. So this is a very easy problem. It can simply be solved. Does it make sense? Do you need more explanation on this one, or do you want me to move on to the, or can we move on to the next problem? I see, yeah. Yeah, that's a good start. Yeah, it's at the beginning that is a good start, and you have to spend maybe years. You know, competitive programming is like this. All the good competitive programmers have spent years so that they are in this level like right now. So it's totally okay to spend years on that. Okay, let's move on to the next one, problem B. Different string. We move on problems one by one. We will reach F, but we have to move. I try to solve the first problems very fast so that we can get there sooner. So the second one, you are given a string S consisting of lowercase English letters. Rearrange the characters of S to form a new string R that is not equal to S, or report that it's impossible. Well, first of all, it's impossible if and only if all the characters are the same. For example, in this case, and in this case. When all of the characters are the same, when you rearrange the characters, they're still all the same, so nothing changes. So if that happens, if all of them are the same, the answer is definitely no. But if they are not the same, it means that there should be two elements that they are not equal to each other. You can just swap these two and you have a string which is not equal to the previous string. You can also say that obviously there would be two adjacent elements that are not the same, because if a1 is equal to a2, or let's call it s, let's call it s. If s1, for example, our string is s. If s1 is equal to s2, s2 is equal to s3, s3 is equal to s4, and so on, then all the characters are the same. So all of these are not true. So for one I, we have that s of I is not equal to s of I plus 1. So we can just swap these two and print the resulting string, and we have our answer. Okay, does this make sense? I don't know in which language you're talking. Is it Russian? I can't understand it. So yeah, we can do that as well. Salam, Yasin. Salam. Okay, does this make sense? Should we move on to the next one? Yeah, you're Russian. Yeah, I guessed that. Awesome. Okay, no problem. Hello to all the Russians who are watching this stream right now. I will have an interview. I will publish my interview with Ors very soon. He's a IMO gold medalist from Russia. And now that we talked about Russia, I mean, that's a good thing to mention. This contest was not hard, I guess. I think maybe the rest of you can say it as well, can comment about this as well, but I don't think it was hard. The example that you mentioned, OCCC, that is true because the first two letters, I in here in explanation I used one-based indexing, but you need to also in code you need to also compare S0 and S1. I mean, in my explanation I used one-based indexing for clarification, but yeah, in your code you have to consider zero-based indexing, and yeah, these two are different and you can swap them. Okay. So is this problem fine with everyone? Yeah, I see a Persian comment. Yeah, I was studying Olympiad in informatics back in school. In Iran I got a gold medal. Yeah, you can also sort it in increasing or decreasing order. That would also work. That would also work. That would also work. Okay, so I guess we can move on to the third problem. Is it okay? Tell me, shall we move, or do you have any more questions about this one? I'm okay with both. Okay, let's move on to problem C. Yeah, we will get to F as well. Problem C says that we have a clock, we have numbers 1 to 12 on it, and we draw two strings, two lines between two pairs of integers between A and B and between C and D. And we want to see if they intersect or not. And they are all distinct. They are all different. So we draw these lines and we want to see if they intersect or if they do not intersect. So how can we solve this problem? Well, this one is a bit more challenging than the previous ones. The previous ones were very trivial. This one is a little bit more challenging, but not that much. Well, the point is, first of all, I think the first good thing that you can do, if A was greater than B, let's swap A and B. I want to make input more structured. Okay. So if A was greater than B, swap A and B, and if C was greater than D, swap C and D. And we know that all the numbers are distinct, so we don't have the case that they are the same. So now we know that A is less than B and C is less than D. It makes your input very more structured. And then if A was greater than C, swap your pairs. I mean, you can just swap A and C and swap B and D. So I'm trying to make everything very structured, and then I'm saying that if they are going to intersect, they should be something like this. We should have A, and then after that we should have C, and then B, and then D. They should be in this order. Do you agree with that? I mean, the only way that they can be is like, for example, in this case, this is gonna be my A, this is gonna be my B, this is gonna be my C, this is gonna be my D. And if we see the order in the ascending order, we see that we first see A, then C, then B, then D. I'm saying that if they're gonna intersect, we should first see A, and then we should see C, and then B, and then D. This should be the order. And that's all. This way, easily we can just find the answer. Find if they will intersect or they do not intersect. Yeah, it is exactly what like what you say. One point should be between A and B. One of them should be between A and B. So C should be between A and B, and D shouldn't be. D should be greater than them. Okay. So the whole point is that first I'm trying to make the input structured. And how do I do that? I first try to make sure that in every pair the first element is less than the second one. So I'm sort of like sorting them. I'm sorting the pairs, and then I compare two pairs. If the second pair was pointing to smaller values, I will swap the pairs as well. I will swap A and C and B and D, and then I know that A is the minimum value. After A, I should have C. I definitely cannot have D because C is less than D. And I should not have B as well, because if I have B, it means that A and B are here, and they would not intersect with B and D, which are greater, with C and D, which are greater values. So B cannot be here as well. So we have A, and then we should have C. And then we cannot have D as well, because if we have D again, we have two strings like this, and they wouldn't intersect again. So the next one should be B, and the next one should be D. So after these swaps, if it was necessary to make these swaps, I will make these swaps, and then after that I will make sure that these values are in ascending order. I mean, A is less than C. I will make sure that C is less than B. I will make sure that B is less than D. Okay. Yeah, so the condition is this. First, I have a if. I say that if A was greater than B, swap A and B. And then I say if C was greater than D, swap C and D. And then I say if A was greater than C, swap A and C and swap B and D. And then I say that if A was less than C and C was less than B and B was less than D, C out yes. Otherwise, C out no. Okay. If this happened, yes. Otherwise, else, no. Does this make sense? Yeah, exactly. If we just consider these examples, those help us a lot to understand what is going on. And not only here, even in contests, if you just try to see what is happening in the input and output in the test cases, in the sample test cases, then you can get a clue of how you can solve the problem. For example, in the first one, we have 2, 9, 10, and 6. Well, first I will check these two. I see that 2 is less than 9. That's okay. I check these two. I see that 10 is greater than 6. So I will swap these two. This one will become 6. This one will become 10. And then I compare these two, 2 and 6. I see 2 is less than 6. So that's okay. Now I'm saying that the order should be like this. The smallest number should be A. The next one should be C. The next one should be B. The next one should be D. And this is true here. A is less than C, C is less than B, and B is less than D. So the answer to this one is yes. About the next one, we have 3, 8, 9, 1. So 3 is less than 8, that's okay. 9 is greater than 1, so we need to swap these two to sort the second pair. Then we compare 3 and 1, and we see 3 is greater than 1, so we need to swap these two. So in here we have 1, 9. In here we have 3 8s. And we see that the order in here is not A, C, B, D. Because D is less than B. So it is not true in here. So the answer is no for this one. And for the last one, we have 1, 4, 3, 5. 1, 4, 3, and 5. We see that these two are okay, these two are okay. These two are okay as well, and we just need to check if it is A, C, B, D, which it is. We know that A is less than C, C is less than B, and B is less than D. So that's all. Yeah. Yeah, thank you. So does this make sense? Yes, exactly. It exactly checks if both of these points are inside or outside, or they are in different size. So when we sort them, then we are sure that C should be between A and B, and D should be greater than them. So it makes everything more structured, and it makes our work easier to solve the problem. Yeah, I will get there. I will get there as well. So do you have any more questions about this problem, or shall we move on to the next one? Yes, if this is the first contest that you participated in, yeah, you're gonna be rated afterwards, after the contest. Yeah. Okay, so let's move on to the next problem. Okay, binary cuts. You are given a binary string. Please find the minimum number of pieces you need to cut into so that the resulting pieces can be rearranged and into a sorted binary string. Well, the first thing that I want to mention when I see this problem, the first thing is that, well, first of all, you will think that all of the parts should either consist of only ones or only zeros. So one idea to solve the problem, that is, this one is not optimal, but one way to make the partitions, okay, is that trying to make some parts that all the elements in the same parts are the same, exactly the same. That is one way to solve the problem. For example, in here we need to have three cuts this way: one cut here, one cut here, and one cut here. And we will have 4 parts afterwards. Okay, so one way to make the string sorted is to just make all of the parts having the same letters. So we have blocks of 1 and blocks of zeros, blocks of ones and blocks of zeros. So we have a block of ones here, a block of zeros here, a block of 1 here, a block of 0 here. Okay, so the point is, we can always do this, but it's not necessarily optimal. Well, the point is, there is only one part that can be of this form. We have some zeros at the beginning of it, and then we have some ones at the end of it. Only one part can be like this. Why? Because if you have only one such part, you can put this one in the middle, and all the zeros before this part and all the ones after this part, and that would be a sorted string, right? So only one part can be 0 0 0 0 1 1 1 1 1. So only one block can be like this. So we didn't need to have these cuts, because we have the right to have at most one part of form that a prefix is 0 and the suffix is 1. Only one cut. I haven't participated in the contest and I have not implemented the code, but I can show you some codes that people have wrote. Maybe if we have access to it already, we will see that. We will see the codes. But all I'm saying is that only for one part you can have a prefix of zeros and a suffix of ones. So what I say is that the answer, first I set my answer to be the number of different blocks. First I partition everything into zeros and ones. I see that how many blocks of ones I have and how many blocks of zeros I have. For example, in here I initially set my answer to be 4. And then I check if there is one position, at least one position, that we have 0 and after that we have a 1. Well, initially I had a cut in here, but the point is for one of them I can just avoid having a cut. So if there was one such position, I will subtract 1 by my answer. If there was no, I just print my answer. So I have my answer, which is blocks of zeros and ones. And then I start and compare each to consecutive elements. And if I had 2 consecutive elements such that the first one was 0 and the second one was 1, I subtract my answer by 1. Because only for one such position I can remove my cuts. Okay. Why can't I count continuous blocks before and after 0 1? You are doing that, you know, I mean, this 0 is in a block itself and this 1 is in a block itself, and when we see this 0 1 we can avoid this cut, but we cannot do anything for the cuts before it and the cuts after it, because in here we have 0, in here we have 1 when we have a cut, so we cannot fix them. And because only one block can be of this form, I can only remove one of these cuts, right? So if we want to look at some examples, in here we can see that we have 1 1 0. This is the sample that we saw already. So the answer is initially 4, as I said, as I stated. Let me zoom in. So the answer initially is 4, and then I see that I have 1 0 1, so I subtract 1 from it, so it would be 4 minus 1, it is 3. In this one the answer is initially 1. I don't have any pairs, consecutive pairs of 0 1, so the answer remains 1. So it's 1 minus 0, which is 1. In this one the answer is initially 1. I don't have any 0 1, so again it's 1 minus 0, it is 1. In here I have 2 blocks, 2 parts. I don't have any 0 1, so it's 2 minus 0, it is 2. In here we have 2 blocks and I have 1 0 1, so I can subtract 1 from it, so the answer is 1. In here I have 3 blocks. I have 1 1 0, so I can subtract 1 from it, so the answer is 2. So each time I will either subtract 1 or I will subtract 0. If there was a consecutive pair of 0 1, I can subtract 1, otherwise I can't subtract 1. And if I compare it with here, this is 3 1 1 2 1 2. It is completely correct, right? And if we see the codes of people, let me bring a code with C. Okay, let's see a code with Python. That's okay as well. Yep. I think that it is doing the exact same thing, because it's just trying to check if we have any 0 1s, and then considers adding it to the answer. Let me also bring a C++ code as well. Okay, for example, in this one you see that when you guess S first. Okay, yeah. Again, in here it is counting, this code is counting the number of blocks. It just says that if S of I is not equal to S of I minus 1 and S of I was 1, it means that it's the answer in here, always when it sees 1 zeros, it adds 1 to answer. When it sees 0 1, the first time it doesn't add anything to answer. You know, it says that ans plus equal to OK. And OK is initially 0, so the first time ans wouldn't change. But from the second time, the answer would be increased by 1, because OK will become 1. So that's exactly the same thing. The first time that it sees 0 1, it doesn't change the answer. But the next one it changes. So that's like exactly, it's like counting the partitions. Only for 1 0 1 you don't count that. Okay. Does that make sense? Yeah. The point is, yeah, how to implement it. If I want to implement it, I just do this. I'll have a 4 on my string. Whenever I see that S of I is not equal to S of I minus 1, I increase the number of blocks. So I say ans plus plus, and ans is initially 1, ans should be initially 1 because at the beginning we have just one block, the whole string. But whenever we see two elements which are not equal, we say ans plus plus. And if I saw two elements, two consecutive elements such that s of I minus 1 was 0 and s of I was 1, I just have a flag and I set my flag to be true. This flag just remembers if we had such a thing or not. And at the end, I just will write ans minus flag. I just print, I just see out ans minus flag. Yeah. So this way we can solve it easily. Does this make sense? Are you okay with that? If you are okay, we can move on to the next problem. Otherwise, if you have any question, we can talk about it. Yes, ans minus flag. Yeah, a Boolean value can be interpreted as a 0 or 1. So if it is true, it would be minus 1. If it is false, it is minus 0. So it is okay if you subtract a Boolean from an integer. You can do that. Okay, next one. The next one. Problem E. Oh, problem E. Find the car. Okay, in this one we have some places 0, A1, A2 to AK equal to N, and we know that at which time we have reached that point. And we know that between each 2 points the speed of car is fixed, is constant, and we need to find out that at what time we are at each position. Well, the point is, this is I think even easier. This is more implementation rather than algorithmic. So I'm just saying that when you want to see that for a point, when you reach that point, it's just enough to say that what was the previous point, what was the last a of I that we had, what is a of I minus 1, and what is a of I. So we want to find the position of, we want to find out that when we reach x. So we find such I such that a of I minus 1 is less than or equal to x, for example, and a of I is greater than x. We find such I. Okay, we find out that between which 2 points x lies. That was a very good question. Are you doing your office hours at IRIP today? Yes, I'm gonna have my office hours at 3 o'clock at IRIP today. Hello to the students from University of Maryland. Yep. So yeah, I will find a of I minus 1 and a of I such that x lies between them, and I see that when I reached here, what was the time that I reached here, and what was the time that I reached here. So I have b of I minus 1 and b of I. Okay. So the point is, if I want to find out when I am at x, I know that the speed is constant between them. So I just need to find out what is x minus a of I minus 1 over a of I minus a of I minus 1. So I know that the whole path between these two is a of I minus a of I minus 1. So I want to see that what proportion of it I had before x. Okay, I want to find the proportion that I had before. Okay, yeah. The question is just saying that I have a car. I know that at time b1 the car is gonna be at a1. At time b2 the car is gonna be at a2. At time b3 the car will be in a point a3. and at time bk, the car will be at point ak. Okay, and I know that between each 2 points the speed of the car is constant. Okay, between each 2 points the speed of the car is constant. So I know that for example, between these 2 points the car goes with the constant speed. It doesn't change its speed between 2 points. Yes, after it reached these points it can change its speed, but between 2 points it always has a constant speed. Okay, so we are gonna move on like this. Yes, the speed can be different between two signs. Yes, between two different signs it will be different, but between the same signs it is constant, right? So I'm just saying that we need to find out what is the proportion of this part compared to the whole part, and we know that because the speed is the same, we know what is the speed. You know, in other words, maybe it's easier if I say it like this. I can find out what is my speed. My speed in here is gonna be b of I minus b of I minus 1 is the time that it gets to reach my destination, right? This is the time that it gets to reach my destination. And what is the distance that I will have in my time, and in this time it is a of I minus 1. So this is my speed. Okay, this is gonna be my speed. And if I just multiply it by x minus a of I minus 1, I will know that exactly what is going to be the time that I will reach x. Right? So we just need to find out the speed first. This speed is gonna be, I'm saying that it would be a constant speed. So let's find that speed. How can we find that speed? We can just say that the answer, the speed will be a of I minus a of I minus 1, which is the which is the distance between the source and the destination, and the time that will be passed is b of I minus 1. So it's gonna be ai minus a of I minus 1 over b sub I minus b sub I minus 1, and I should multiply it by x minus a of I minus 1, and this is gonna be the time that it gets me to get to here. And I definitely should add b of I minus 1 to it, because it takes me b of I minus 1 to get to here. So to get here I will have b of I minus 1, and from here to x it takes this much, right? It takes this much. Does it make sense? So that's all. This is how that you can find the answer, the exact answer, and then the only thing that you need to do is to round this value down, which is very easy. I mean, you just need to find out what is the greatest integer less than or equal to this. Let me, for example, bring a code for this one as well to see how it is implemented. Oh, you can't see the right part of the screen. That's bad. Let me fix it for a second. Let me move myself here and make myself smaller. Okay, so this was what I was talking about. I'm sorry for that, and thank you for mentioning it. Yes, yeah, I see that some of you didn't understand it well, so I will explain it again. I'm just saying that let me first, there are some people who are saying that they didn't understand the question, so let me explain the question again first. The question is, let us read the statement again. Timur is in a car traveling on the number line from point 0 to point n. Okay, so it wants to go from point 0 to point n. The car starts moving from point 0 at minute 0. There are k plus 1 signs on the line at points 0, A1, A2 to AK, and Timur knows that the car will arrive there at minutes 0, B1, B2 to BK, respectively. The sequences A and B are strictly increasing with AK equal to n. Okay, so there are some signs, and we know that the car will reach sign number I at position AI at time BI. And between two adjacent signs, the car travels with a constant speed. So the speed will be constant in between each two signs. And Timur has queries. Each query will be an integer d, and Timur wants you to output how many minutes it takes the car to reach points d rounded down to the nearest integer. Okay, so this is all the problem is saying. So the speed between each two is the same. Between each two signs is the same. So now what I can say is that when I want to see that what is the time that I will reach some x. Okay, I want to see that when I reach these points. Well, I'm saying that I can easily find out what is my speed between these two signs. The speed between these two signs is gonna be A2 minus A1 over B2 minus B1. Because I know that the car is here and at minute B2 and it is here at minute B1. And I know that the point here is A1, the position of this sign is A1, the position of this sign is A2. So I need to see that what was my distance and how long it took me to get there, right? So I can just say that it is between these two signs. And then I know that this is the speed, and so I can find out when I have the speed, this is my speed. Okay, and I know that I will reach x from I know that when I want to go from A1 to x, it's gonna take me x minus A1 times my speed. So I need to find out what is the distance and multiply divided by my speed. I'm sorry for that. Divided by my speed. Right, so I can see that what is the distance and divided by my speed. As my speed is greater, the time would be less, right? And then I can just add it to the value that it takes, the time that it takes to get from 0 to A1, which is going to be B1. So my formula will be like this: B1 plus x minus A1 over A2 minus A1 over B2 minus B1. Okay, so I'm saying that it can be easily calculated. We first calculate the speed, and for each x we need to find out what are the nearest signs. And yeah, we can, for example, use lower bounds for that. And then after I found the closest signs, I can find out the speed between these two signs, and I can find out how does it take for it to come from the last sign to this point, and I can add the value, the time that it took to get to that sign. And this way I can easily find the answer. And if you want to see a code for that, for example, I open this code. It is implemented in while-based, and you can see that it first finds the latest sign before x, and then it does the exact same thing. It says that ans is equal to b of xb plus x minus a of xb, which was the last sign, times. This is just in order to cast everything to doubles, because it is integer already, but we don't want to use integers in these products, because we need doubles to calculate it precisely. At the end we will cast it to ints. This value is an integer, so at the end we can cast it to int and it would automatically round it down. But for now, we need to have doubles to calculate this, but first we have to calculate it precisely, and then we can get the final answer and round that final answer down. Okay, so we have x minus a of xb times 1.0 to make it double times, in here we have the time that it took, in here we have the distance that we had. You know, if you see here, we had what we were doing was that we had this speed, and we say that we have x minus a1 over this speed, so it's gonna be over a2 minus a1 times b2 minus b1, because in my speed I will have it divided by b2 minus b1, so it is like times b2 minus b1. The same thing happens here. It is time the difference of the b's and divided by the difference of a's, and then it will be casted to n's, to an integer which is n's. Yes, this lower bound will find the greatest integer less than or equal to x. Lower bound is binary search. It does binary search itself. It's a binary search that C++ has implemented it itself. So when you say lower bound of something, it will just find the greatest integer less than or equal to that. Okay, and that's gonna be all. Does this make sense? So it finds the greatest integer less than or equal to x. So it's gonna be the last sign before x. Yeah. So is it clear now for everyone? If you're okay with that, put a plus. If you're not, put a minus. If you completely understood, put a plus, please. Otherwise, put a minus. Yes, lower bound returns the index. Yeah. Yeah, we will move on to f. The next one is f, and we finally will discuss f. I know that a lot of you were waiting for f. Okay. So circle perimeter. So given an integer r, find the number of lattice points that have a Euclidean distance from 0 and 0 greater than or equal to r, but is strictly less than r plus 1. And the lattice point is a point with integer coordinates. For example, 1 and 1, 2 and 2, 1 and 2. All the points that their coordinate is a pair of integers, right? No, a plus 1 is a of 1 for an array. That was an array. It throws a of a plus 1 because it was 1 based indexing. Okay. So is the problem statement clear on problem F? Okay. So we need to find all those points. Well, first thing first, let's make this problem a bit simpler by just applying a very simple idea, prefix sums. Well, I will just, instead of having two bounds, I want to have just one bound, just upper bound. Instead of having lower bound and upper bound, I just want to have upper bounds. So I will, sorry, the voice was opened on my phone. So I'm saying that instead of just trying to find the points that their distance is greater than or equal to r and less than r plus 1, I will solve this problem instead. I will find all the points that their distance is less than r plus 1 once, and then I will solve the problem for less than r once, and I will subtract these two from each other. This is the prefix sums idea. I will just, this way, this is a very good idea, because this way I don't need to be worried of this bound. I can just solve the problem, write a function and solve the problem for just my upper bound, And then I can call this function twice and just print the answer. So first of all, I can get rid of my lower bounds. Okay. Yeah, I will explain the question again. It says that given an integer r, find all the points that they have integer coordinates. I mean that the coordinates should be integer. For example, you cannot have, for example, 0.5, 0.7, for example. Your points, your lattice points, they are called lattice points, are for example 1 and 1, 1 and 2, 1 and 3, 2 and 1, 2 and 2, 2 and 3, -5 and 5, for example, anything like that. So they should be integers. So you need to find out how many integer points do we have such that their distance from 0 and 0 is greater than or equal to r, but is strictly less than r plus 1. Is this statement clear? Fahmi? So that's the whole thing about this. That is only one line problem. I love these problems that the statement is just one line or so. Okay, so now for example, I'm just saying that we can define a calc function that only gets the upper bound. It doesn't care about lower bound. It can just get the upper bound, and it will tell you that how many points we have, how many lattice points that we have, such that the distance is less than upper bound. It doesn't have any lower bound anymore. We don't care about lower bound. If we can solve this problem, if we can only solve problem for these parts, for the upper bound parts, then we can call this function twice, and we can just say that the answer is going to be calc of r plus 1 minus calc of r. So this way we make the problems a bit simpler at the beginning. We just care about the upper bound, and we just say that we have calc of r plus 1 minus calc of r. Okay. So this is the first thing that comes to my mind when I read this problem. And this is very easy, because if you just are familiar with prefix sums, the first thing that you think of is this. Okay, let's make the problem easier in my first step. I just look at it like this. And now when I want to do this, it looks like a simple binary search. Why? Because r is up to 10 to the power of 5. If I just fix, for example, the y coordinates, if I fix that, I want to have this y coordinates. Y can be at most 10 to the 5th, because r is at most 10 to the 5th. Or in other words, y can be at most r. Otherwise, the distance is obviously more than r. Now, by using only a binary search, I can find out what is the last point such that its distance to the origin is at most r. Is at most my upper one. Let's call that r. I want to count all the points that their distance is less than, or let's say x is less than, let me say d. Maybe this is the best option. So I will find all the points that the distance are, the last one that the distance from the origin to it is less than d, is strictly less than d. I can find that with a binary search, right? Yes, yeah. So using binary search, I can find that how many points are okay in this row, in this line. So I can sum these values up, and easily I can find the result of calc function, and I can return it, and then using that I will solve the problem. I mean, I just need to find out what is the calc of r plus 1 minus calc of r. Does this make sense? There were many people waiting for problem F. Now that we're discussing problem F, did you understand it? If you understood everything, put a plus, otherwise put a minus, or ask me questions if you have any questions about any part. So if I want to repeat, I just solve it for an upper bound. I can get rid of lower bound easily, and that makes my mind makes the work for my mind very easier. And then I can use binary search. I can fix y, and using a binary search I can find what is the last one that its distance is less than d. And for each row, for each line, for each horizontal line, I can easily find out how many points are wrong. Yes, you can also approach it differently. You can also solve it without binary search. I guess you can solve it using algebra, but worst case scenario, you will use binary search. If you will use algebra, when you fix your y, you need to know that x squared plus y squared is less than d. So x squared plus y squared, and y is fixed, is less than d squared. So x squared should be less than d squared minus y squared, right? So yes, using algebra we can just find it. So you can say that x should be less than a square root of d squared minus y squared. Yes, you can say this. With algebra you can also say this. Instead of binary search, you can find the formula and you will find the last x, which is good. You need to find the last integer less than this value, right? So this way you can also find the last x, but you can also use binary search. This is mostly the mathematical solution. Binary search is mostly the I don't know, competitive programming ish solution. But yeah, I agree that this one is faster, its time complexity is better, but that one also gets accepted, and maybe it's with me easier and you don't need to get into algebra. Both of them are fine. Yeah, I agree that this one has better time complexity, but both of them are fine. And in order to find the total number of lattice points, I just need to add these values up for these values up for all the horizontal lines. For each specific y, I need to find out how many points are there. Okay. Yes, we can, yeah, exactly, we will find symmetry. Yeah, when we find this x here, we can also say that on the other hand we have minus x, so there would be exactly 2x plus 1 points here, and we can just sum these values for positive values, and we know that the negative values, negative integers have the same value, so we can multiply that by 2 as well. Yes, exactly. So is this problem okay completely? Code, yeah, we can also see some codes in problem F. Let's see this code. Yeah, seems like has done the same thing. It gets n, and for I from 1 to n, so it fixes the horizontal line, for example, and then it says that we have a square root of n plus 1 times n plus 1 minus I times I minus 1. You know, as I said, we need to subtract these two values. This code is subtracting these values each time. Instead of adding all these values and summing them up, and adding all these values and summing them up and subtract them from each other at the end, it subtracts them at the moments that it wants to add it to the answer, right? So that's how it works. So each time it's when it goes over all these lines, first it calculates that how many points in that row have distance less than n plus 1, and then subtracts how many have distance less than n. And the formula is exactly the same as we see here. A square root of d squared minus y squared. Okay, in here we have n squared minus I squared. And that minus 1 is because it wants it to be less than that value. It doesn't want to be exactly that value. So it subtracts 1 from it so that after that it can round it down and therefore find the greatest integer less than or equal to that value. As I said, it should be less than n squared minus I squared if we use these variables. But it subtracts 1, I think, because it wants to find the numbers which are less than or equal to this. That's what I feel. Does this make sense? What about cases like x and 0? You can multiply that by 4 times, right? I think that's that is counted here when it sets ans equal to 1 initially, and it is going to multiply it by 4. So I think in here the ans, your ans is 1, I guess, because of these 4 points: 0 and x, 0 and minus x, x and 0, and minus x and 0. So I guess this initial one is for these 4 points, because in the rest of them the number of rows and columns are greater than 0. So I guess that case is counted there. These 4 points, it has added 1 and it will multiply it by 4. These are the points which are on the x-axis, so they are counted separately. The rest of them are exactly in one of the quarters, so you can multiply them by 4. Yeah, as I said, there's no binary search in this one. As I said, we have 2 ways. Either we use binary search or we use algebra. As I said, we can also use algebra in order to find the greatest value of x. We do not necessarily need binary search. Binary search is more competitive programming-ish. Algebra is more mathematician-ish, you know. And why are we adding all in a loop? Because each time we are considering all the values in one row, right? So we have to add all these values up, because each time we're seeing that in one specific row, how many good points do we have? Yeah, and he has brute force for one quadrant. Yeah. Yeah, this is exactly algebra. This is exactly the algebraic way to solve it. He hasn't implemented binary search. He has implemented algebra for this one. Okay, shall we move on to the next one, or do you have any questions about this problem? Mathematics, yes. Yeah. Okay. So let's move on to the next problem, problem G. Well, in this problem, you are given an array A consisting of n non-negative integers. You can swap the elements at positions I and j if A of I, A sub I, XOR A sub j is less than 4, where XOR is the bitwise XOR operation. Find the lexicographically smallest array that can be made with any number of swaps. An array X is lexicographically smaller than an array Y if in the first position where X and Y differ, x sub I is less than y sub I. Okay. About the previous problem, if you want to see the binary search implementation, I'm not sure. I think if you have some, if you search the codes, if you check them, you will find one that has implemented binary. Yeah, for example, this one has implemented binary search. So yes, this is a code. You can see its ID, his ID or her ID, and just see that's how he's done it. He has used binary search. Okay. So, no, I didn't solve ICPC challenge by Huawei, unfortunately. And why subtract one? Because as I said, it should have been less than that value. I guess that subtraction by one was because trying to find the less than or equal to that value instead of less than that value. Yes, this video will be uploaded. Yeah, after the stream you can watch the video again. Yeah. Okay, so yep. So in here you can just swap two elements if AIX or AJ is less than 4. And you want to make it lexicographically smallest. How can you do that? Well, the point is, it's like we will have some connected subtrees, subgraphs, I can say. I can just draw an edge between two elements if and only if their values, the x or of their values is less than 4. What does that mean? It means that if we divide them by 4, they are the same. Or if we write them in base 2, only the last 2 digits are different. So I can swap x and y if and only if x divided by 4, floor of x divided by 4 is equal to the floor of y divided by 4. I can do it if and only if this happens. I can swap two elements if and only if this happens. For example, in here, for all of them, this value is 0, so I can swap all of them. In this one, I can swap 1 and 2. I can swap 7 and 5, 7 and 6, and 5 and 6. So it's like these two are one component, these three are one component. Okay, so I can swap them in this situation when this happens, right? When this happens, I can swap them. So at the end, I will have several connected components, and it's enough to sort each connected component independently. When I sort each connected component independently, for example, in this one, 1 and 2 should be in sorted order, and 5 and 6 and 7 should be in sorted order as well. So I can just sort the ones which are in the same connected components. And that's going to be all. I just find the connected components and sort each connected component individually. Right? Does that make sense? So that is going to be all I will do. If you're okay with that, put a plus, otherwise put a minus. So I will just, between each two elements, if they divided by 4, they are the same, I can draw a line. And I don't need to draw the line between each two numbers like this. I can just say that what was the last number that's divided by 4 was equal to this. For example, when I see some x, I can say that last of x divided by 4 is this index, this specific index. And before that, I can just draw an edge between x over I and the index of the previous x over 4, sorry, and the index of last of x over 4. So I can just add an edge between these two. And I can just save that these are in the same components. Or I can have a vector for them. I can have a map from integer to vector. That would also work. And then sort each vector at the end and put all of them in the indices that they were from. So the idea is only this. Just make this somehow, make this connected components and just try to sort all of them. If you're okay with that, put a plus, otherwise put a minus. There's only one problem left. I'm not sure if I read this one as well. Okay. I will talk about the next one as well. I didn't have a chance to think about the last one, but I think we can solve it here together. Yes, exactly. For me also this felt easier than F. Exactly. Yeah, there are several problems that seems like they are not sorted. I also believe that this one was easier. Let me see that which one got more accepted. Which one had more accepts? They are almost the same. This one is 2360, this one is 2308. Maybe if they were swapped, if their positions were swapped, this one would have more accepts. So when they are this similar, it can mean that this one was easier, because people naturally try to solve the first one first. Maybe if the position of these two were swapped, this one could make more accepts. Yeah. Okay, so let's move on to problem H. If you don't have any question from problem G, well, I will first tell you about problem H. The problem statement: Bob has a grid with 3 rows and n columns, each of which contains either a sub I or minus a sub I. For some integer I from 1 to n, for some integer from 1 to n. For example, one possible grid for n equal to 4 is shown below. So you see that each cell is either one a of I or minus a of I. It's either one of these, right? And Alice and Bob play a game as follows. Bob shows Alice his grid. Alice gives Bob an array a1, a2 to an. Each element is either -1 or +1. So Bob constructs this matrix, and Alice would set each of ai's either 1 or -1. Okay. Now Bob sorts the elements of each column in non-decreasing order, and Alice wins if all the elements in the middle row are 1. Otherwise, Bob wins. For example, suppose Alice gives Bob this array, then this grid will turn into this one. For example, a1 is 1, so it becomes 1. Minus a2, I know that a2 is -1, so that one will also 1. Minus a3, I know that a3 is -1, so this one is also 1, and so on. And then Bob will sort the elements of each column in non-decreasing order, and if the middle one is 1, if the middle row is 1, Alice wins. Otherwise, Bob wins. Is this statement clear? If you're okay with it. Now I think I have the solution, and it seems like very interesting. It seems like an interesting solution, and afterwards I will talk a little bit with you if you had any questions outside of this contest and any suggestions. But yeah, what I see is that this one is this problem looks like a good problem. If you have any question about this statement, tell me to explain it again. Otherwise, we can discuss the solution. Yeah, the first thing that comes to mind is that each row should have at least 2 ones, right? So each column should have at least 2 ones at the end. So we should set them in a way that at least 2 of them will be 1. That's the only way that when we sort them in increasing order, in non-decreasing order, the middle row will be 1. In other words, it means that in each column, if you consider each two elements, they cannot both be minus ones. So for example, it's not possible that minus a2 and minus a3 are both minus ones. It's not possible that minus a2 and a4 are both minus ones. It's not possible that minus a3 and a4 are both minus ones. Right? So the point is, at each column, if we consider any two of them, they cannot be both minus ones. Because if they are, we have two minus ones in that column, and therefore the middle row will have a minus one. So this gives you the idea of two sets. Why? Because assume that for each a of I, you want to set it to be 1 or minus 1. It is exactly like two sets. In here, you know that either when you have minus a2 and minus a3, at least one of them should be 1. So it means that either a2 should be false or a3 should be false. And assume that true means 1 and false means minus 1. So one of these two should happen. And for example, either a2 should be false or a4 should be true. And either a3 should be false or a4 should be true, and so on. So it's like we have 3n clauses, and it is like a simple two set, and we can just solve it and try to find the values. And this is just solving a two set, and that's all. This looks like a bit this is a bit classic, but it's an interesting problem. So yeah, you need to know what is two sets in order to solve this problem. If you don't know this, if you don't know what is two sets, maybe it's better if you don't try to solve this one first. Try to solve the previous problems first, because maybe you haven't solved G and F and E as well. But if you know two sets, this is how it can be solved. Does this make sense? If you're okay with that, again, put a plus, please. Otherwise, put a minus or ask me questions about this solution first. Okay, I guess that there are no questions. You are still welcome to ask. Yeah, you're welcome. Thank you for joining. It is so nice to have audience from different nationalities. Guys, where are you from? Can you all say that where are you from? From where you're watching the stream? I want to see how much diversity do we have. Yeah, you're welcome. Thank you for joining, and it was nice to interact with you. Really. India, Belarus, Tunisia, Bangalore, India. Yeah, you're welcome. Thank you. India, Taiwan. Awesome. Any other countries? How many unique countries do we have? For example, if anyone is not from the countries mentioned here. Yes, awesome. Yeah, I'm also originally from Iran, but right now I'm studying in United States, in University of Maryland. Yeah, awesome. Bolivia, awesome. Awesome. It was very nice to have you all in here. I really enjoyed this stream. I hope you enjoyed it as well. If you have any suggestion to improve These streams that would be welcomed, very welcomed. I would love to make this stream better. I would love to have even more streams for you. There wasn't enough streams. There wasn't, I'm sorry, enough contests so that we could have streams. So I'm really thinking of having some streams other than contests. And I'm really thinking about it. That how can we do that? I mean, how can it be useful and many people want that? I'm really thinking on it. I'm working on it. If you have any suggestion for that, you can also say that. But uh, yeah, I think because contests, there are so many few contests lately, and that is not very good. I don't know if tomorrow is a ad coder contest or not, because most of them Saturdays and Sundays there are ad coder. Okay, yeah, it seems that tomorrow is a beginner contest and the day after that is a regular contest. So maybe I will stream that ones as well. Yeah, with high probability, I will stream those as well. I would love to see you again tomorrow. Thank you very much. Yes, I would love to. Yes, you're right. Yeah, there has been a while that I haven't uploaded new videos. I'm just doing live streams because of some issues that I had. But I will restart that with more power for sure. And I'm even talking with others so that they will also make some videos for you, and that would be great that way. Yeah, sure. I'm so happy to hear that they are useful. Yeah, about improving on number theory and math-based problems, you need to solve many problems. Maybe I will have some live sessions solving some topics. For example, solving the topics of number theory or math-based problems, and we can solve them together. I mean, would that help you? Are you interested in joining such a stream? For example, we have another stream like this, and we just try to solve various problems with different difficulties on number theory, for example. Uh, is there a smarter way to solve this than two set? I did two set on the contents, but it seems weird to see it on a D4 without a more clever solution. I guess two set was the main solution. We don't have tutorial yet, but let me see the codes of others. It seems like even the smallest codes, even the code with the lowest size, has used two sets. So I guess the main idea, the solution is two sets. The main solution is two sets, I guess. I think there are no other ways. Yes, it's some sort of look like an educational contest, maybe this way. They wanted to show the idea of using two set to solve a problem, I guess. Yeah, if you like that idea and you will join, yeah, we can have another stream and just try to solve some number theory problems or DP problems or segment problems, etc., etc., and that would be great, I think. Awesome. Yeah, if you need to improve, it really depends on your current situation, on your current level. But most of the time, it is good if you try to solve problems from Codeforces at your own rating. It doesn't need to be higher than your current rating. I really believe in that. Even if you solve problems with your current rating, that would be great. Problems with difficulty of your rating, because you are not still able to solve all of them. If you solve all of them, your rating would be way more than that, because there are some problems there that you sometimes solve, you sometimes don't solve. So that's difficulty of your rating is a good difficulty to solve more problems from, and that would help you a lot. I had the same experience. If you see my chart, you see my own experience and my own journey and how I had growth. So yeah, I believe that solving the problems with the same difficulty would be great, and that would be very good. Yeah, you have chance to improve, definitely, and I will try to help you as much as I can, as much as I can. I try to help you to do it better. Goodbye. It was nice to have you here. I can't read your name, but goodbye. And what is TwoSet? You don't need to learn it right now. It is a complicated thing, relatively complicated algorithm, so you don't need to solve know it right now, but you can learn it later. So you can skip the last problem for now. You do not need to solve it. Yeah. Okay. It depends. If you want to reach pupil, no topic, just implementation, brute force, mathematics. No specific algorithms, just these topics, and solve easy problems, 800s, 900s. Solve very easy problems. If you're a newbie, solve easy problems, 1,000. So sort problems in Codeforces by their difficulty and start solving them one by one. That's what I did, and you can see the effect of it. Let me show you my charts. That's exactly the same thing that I did. I solved the problem by the difficulty and I started to solve them. I sorted them by the number of people who have solved those problems. You can see that my rating was this. Back in that time, your rating was starting at 1500 in Codeforces. That's why initially my rating was greater than that. But my rating was 1119. And you can see that this is March. And you can see that in May, only 2 months after, I reached experts. So in 2 months, I got from newbie to experts. And how I did it, I just sorted the problems in Codeforces. Sometimes I was reading people's codes. That was very useful. When I was thinking on a problem and I couldn't solve it, I was reading people's code. And that was very useful for me. That helped me to learn a lot. That was really good. And you can see that here I won rank 4 on a div 2. Just 2 months, or now 3 months after I was a newbie. So yeah, this was a golden time for me. I solved a lot of problems from Codeforces, and that was very good. And yeah, and I continued this path until here. And then after that, I didn't have the chance to. I had many different responsibilities after that. I came to the university and I had many other responsibilities, and I couldn't study competitive programming a lot. For example, you see long periods of time that I didn't participate in contests. But anyway, I kind of improved slowly after that as well. Yeah, you're welcome. At that time, I was doing high school. At this time, I was doing high school, and I was learning competitive programming and Olympiad. Yeah. Yeah. Thank you all for joining. So see you soon. I will think about the idea of having streams of solving specific topics. Thank you very much. That's so nice to hear that. Well, Codeforces is better for training, especially when you have started. But the type of the problems in AtCoder are so great as well. They have so many beautiful problems that I really love. So AtCoder has really beautiful problems, but yeah, the best source to learn competitive programming, especially when you want to start, is Codeforces. It's better that whenever you participate in a contest, try to upsolve the contest, try to solve the next problem that you haven't solved after the contest. When you, for example, hear the solutions in the streams, try to accept them afterwards. Try to implement them and accept them, and that would really help you. And also sort the problems and try to solve them one by one. That would be great, and you can solve the problems around your current rating, with difficulty around your current rating. That would be really useful, I believe. Yep. Okay, guys, so I guess I see you soon again. I hope there would be more contests, and I hope that we can start our streams on various topics other than just contests. So yeah, of course, I will give a small lesson on how to use Codeforces. I already have a series of videos on starting competitive programming, and one of them is on Codeforces. So if you want, you can see that. But yeah, I will make another one about Codeforces. Yeah, thank you very much. I will do that, and I hope that it would help you a lot, and we can both grow together more than ever. Okay, so see you the next time. Goodbye for now. Thank you very much, and good